Hi everyone, I'm Zach Jankowiak, and my topic is the cognitive effects and effectiveness of using augmented reality systems in vehicles. So, augmented reality is a technology that connects the real world to the virtual by overlaying digital information onto objects or places to inform the user or enhance their experience. Some potential applications of AR in vehicles are safety and road hazard cues that could inform the driver, navigational elements, multimedia control, and increased awareness of the environment. Most current augmented reality systems fall under the center console augmented reality display category. These systems render and overlay digital objects or information onto a live view of the driver's environment through a center console display. Some examples of this are Mercedes-Benz's MBUX system, which gives drivers navigational cues or information, and GMC's invisible trailer, which allows drivers to essentially see through a trailer they are towing. The benefits of center console augmented reality displays can be seen in navigation, where live view navigation systems like MBUX can give drivers context-aware navigational cues like arrows, street names, and location information. Augmented reality navigation systems like this can reduce drivers' cognitive load as they are more consistent with their cognitive maps, which are their ability to accumulate and construct spatial and temporal information. Studies on conventional 2D navigation and augmented reality navigation systems have shown that users have a significantly higher confidence in and greater preference towards augmented reality-based systems. Some potential drawbacks to this type of system can be seen in the fact that users need to look down and take their eyes off the road to access information. Future applications of AR in vehicles will make use of augmented reality windshield displays, which overlay objects and information directly into the driver's field of view. Wayray is a company currently working on this technology that would give drivers a full windshield AR system powered by a widescreen laser hologram projector. The primary benefit to this type of AR system is that it allows drivers to keep their eyes on the road while accessing information. Studies have shown drivers using augmented reality windshield display systems react quicker to road hazards, have a more consistent driving speed, and maintain better awareness of the road when compared to center console 2D displays. Augmented reality windshield display systems can improve navigation by overlaying directional information into the driver's field of view, relieving them of the cognitive strain caused by interpreting 2D maps on their center console display. In terms of safety, this system can give visual cues that improve driver safety in lane-changing maneuvers, detection of road hazards, and give increased perception in poor weather or lighting conditions. Drivers can also have improved multimedia control and greater visibility of system status. Older drivers may see the most benefit from these types of systems as they can compensate for deficiencies in vision or driving ability through the context-aware environment information they can provide. Potential issues with augmented reality windshield displays can occur if the system provides cues that obstruct the driver's view of the environment or draws their focus off the road. Safety is a strong concern for many users when choosing a vehicle with AR systems. One concern is addressing driver inattention, which accounts for 78% of vehicle accidents. Depending on the interface design, AR visual cues may obstruct the driver's view of the environment. They can also be seen to cause inattentional blindness, which is when the driver is focused on another element, such as a text message on an augmented reality windshield display, causing them to ignore unexpected changes elsewhere in their field of view. Another potential hazard of using AR in vehicles is risk compensation, where users become overly confident due to safety cues from the system. To address these issues, an augmented reality windshield display should limit non-essential visual cues to the peripheral and reduce the saliency of those cues compared to those related to operating the vehicle. It should also provide road hazard cues with a sense of urgency and danger to prevent users from being accustomed to those warnings. Visual cues should be adaptive to the environment so they can be seen in all lighting conditions, as well as being easily learnable so that users can handle most tasks with automatic cognitive processes. I found some interesting points about in-vehicle viewing tendencies in an experiment where users were told to locate a song on a center console display while driving. The results from this suggest that more objects on the screen increases the time it takes to complete a task, which was associated with the greater amount of glances down to the screen with increasingly longer durations. The findings from this experiment suggested that data presented in a list structure resulted in shorter and fewer glances when compared to a grid structure. Additionally, a scroll bar oriented on the left side of the screen decreased the mean glance duration and maximum glance durations. That's all I have. Thanks for listening to my presentation.